Okay, quick tutorial on how to set up the UV-Vis spectrophotometer to measure the absorbance through thin film materials. So I've got a couple samples here. These are FTO glass with different materials coated on them. This one is a perovskite material, and this one is just a thin layer of TiO2 on the glass. It can be handy to label which side is the actual film side, if you can't tell. This one's pretty easy to tell. This one is hard because it's transparent. Best thing to do is lay out a Kim wipe or some other inert substance against the bench so you don't contaminate the bench or your sample, and then tear off a few pieces of Scotch tape about the length or a little bit longer than the longest axis of your film, and the tape is going to be used to secure these inside the spectrometer. Alright, so you're going to take the first two pieces of tape that you cut and apply them just on the outer edges of the back of the sample. So notice I flipped the sample. It was saying top, so I want my tape on the back side. So I flipped this so it's film side down so that my tape doesn't actually destroy my sample. It's against the back of the glass here. And so I'm going to apply two pieces of tape, touch them so that they're in contact, but don't let them touch a Kim wipe because you don't want to peel away your Kim wipe. So now we're looking inside the sample compartment of the UV-Vis, and this hole, this slit, this is where the beam comes. So the beam and the lamp come from over here, they come around this corner, and they exit here, and they typically go through a solution like a cuvette. In this case, you can't put your sample inside the cuvette because it's a solid, so you're going to tape it against the exit slit of the lamp, and you're going to tape it with the film facing the lamp. That's why we taped to the back side. So this side that I'm touching, this is not the film side. The film side is facing against the lamp, so the light's going to come through the film, then the glass, then it's going to move through the empty compartment of our sample to the detector at the exit slit over here. Just like any UV-Vis or absorption experiment, you need to first blank the system and tell the system what is 100% transmission. And in previous cases of solutions, you would do this with a cuvette filled with typically water, whatever the dissolving solution is, whatever the solvent is. In this case, you're going to use a blank piece of your substrate with whatever material or materials that you don't want to contribute to the absorbance spectrum. So in this case, I grew my perovskite thin film, my actual colored sample, on the surface of TiO2 on FTO glass. So this is TiO2 with FTO glass. This will be my blank sample. One more thing, it's really important to notice I didn't put tape across the entire back side of this because I don't want the tape contributing to the absorbance spectrum, because the tape will absorb some light and scatter some light, and so I'm taping only the periphery so the path of the light beam does not interact with the tape. That's super important. Okay, so to measure my actual sample, after I've measured the contribution from my blank, same thing. I apply two pieces of tape for the upside down sample, so film side down, apply the tape to the back of the substrate. Now I'm going to apply the taped substrate to the exit slit here, and then rerun the same exact absorption spectrum now that I've already recorded my blank, and that will give me an absorbance spectrum for only the film that I have. It's really important here, again, there's no tape in the path of the beam, and that you have this pushed flat against the exit slit. You don't want it moved at an angle because that'll change the path length. So keep it flat and be really careful when you're applying this so that you don't scratch your film.